if the component dimension is 1 centimeter, you cannot assume the same phase, same magnitude for the entire component description. So that is why in microwave we have to use transmission line theory, where the voltages and currents are functions of distance. That means the voltage varies with respect to distance. Then in that case, the circuit has to be broken down into number of sections, so that each section you can consider that to be a lumped element. So this is how we try to analyze the transmission line in terms of circuit components. So this can be done because the dimensions of circuit are comparable to the wavelength according to the formula, right? So lambda equal to rho c by f. Since the velocity of light at which electromagnetic wave propagate is 3 into 10 power 8 meter per second, and if you go to high frequency, the lambda may be in centimeters, where the device dimensions are also in centimeter. And if you go to still higher frequencies, the lambda will be in millimeters. So if you take a component of 10 millimeter, then inside the component of 10 millimeters, the signal or the microwave or the high frequency wave will change its phase and amplitude number of times.